Okay, hello everyone. So today we'll be going through question 4, 13, 18, 21, 22, 23, 25, 26, 31, 34 and 35. If you think you need help in any other questions, please find me for consultation. So firstly, let's look at question number 4. So question number 4 is a question on purity. Okay, so let's read the first line. In the separate experiments, the melting point of W was found to be 69.5 degrees Celsius. When they say that the temperature of the melting point is 69.5 degrees Celsius, we say that it has a fixed melting point. And if the melting point of a substance is fixed, it will indicate that it is pure. So based on the first line, I can conclude that W is a pure substance. And we should know that a pure substance is either an element or a compound. So based on the first line, we can eliminate option A and we can eliminate option D. So W is definitely not a mixture, and W may not, this statement may contain stearic acid, because the word contain would mean that it's a mixture. So let's look at the next line. It says that this temperature is somehow the same as pure stearic acid. So that's quite interesting. So we want to confirm whether W is actually stearic acid or not. So what we do is that we mix W, which is unknown, with a stearic acid. Then when we tried to melt this mixture of W and stearic acid, the mixture actually melted at 68 and then it stopped melting at 69.5. So that means it's melted at a range between 68 to 69.5. So that this will indicate that the melting point is a range. So if the melting point is a range, it will indicate that this substance is impure. And we should know that when something is impure, it will indicate that it is a mixture. That means it is two different substances mixed together. And if W and stearic acid mixed together cause the melting point to be a range, that would mean that W and stearic acid are different substances. Question number 13. Which element would be expected to form an ion with the largest ionic radius? So firstly, we should first write the electronic configuration of the atom. So for chlorine, that will be 2.8.7. How do I know this? I check the periodic table. Fluorine will be 2.7. Magnesium will be 2.8.2, and then oxygen will be 2.6. So the atom has this electronic configuration, but the ion, we will know that chlorine would be formed 2.8.8, fluorine will be 2.8, magnesium will be 2.8, and then oxygen will be 2.8. So we can see that chlorine contains 3 shells, but fluorine, magnesium, and oxygen all only contain 2 shells. That means that the 3 shells has to be the biggest, right? So over here, the answer should be A. Moving on, question 18. Over here, question 18, which compound does not contain ionic and covalent bonds? So if there's a compound that contains both ionic and covalent bonds, it will most likely be an ionic salt, right, that contains a polyatomic ion. So what is a polyatomic ion? Poly means many, atomic means atom. So a polyatomic ion is an ion that contains many atoms. So chloride ion contains only one atom. So this is not a polyatomic ion. This is not a polyatomic ion, but hydroxide, sulfate, nitrate, carbonate, ammonium. These ions contain multiple atoms covalently bonded together in the polyatomic ion. So how does this look like? So if you look at calcium chloride, you will have calcium ion and Cl minus. So there is only an ionic bond between the calcium and the chloride. There is no covalent bond. However, if we look at something like magnesium nitrate, we have the magnesium ion and we have the nitrate ion, which looks something like this. Okay, how to draw it, you're not expected to know. But however, there is both the ionic bond between the oppositely charged ions as well as the covalent bond between the non-metal atoms. So we got the non-metal atoms, they share electrons, they form a covalent bond. So what this question actually means is that which compound does not contain a polyatomic ion, and therefore nitrate is a polyatomic ion, carbonate is a polyatomic ion, and sulfate is a polyatomic ion. So calcium chloride would therefore be the answer. Okay, next we have question number 21. Question number 21. Which of the following solutions has a concentration of 1 mole per dm cube? So this is actually, it has multiple chapters in it. So firstly, it has things on chemical bonding, right? Because we know that ionic substances, right, ionic compounds contains ions, right? So only ionic compounds contains ions. It's also in the chapter of acids, because we know that acids are special simple molecules, right? Acids are special simple molecules that when dissolved in water will produce H plus ions. That means these simple molecules are so special, they are not ionic compounds, but when they dissolve in water, they form ions. And lastly, the last chapter that's tested in this question is a chapter on salts, especially on which salts are soluble and insoluble, because we know that insoluble salts will not dissolve in water and will not form ions in water because it cannot dissolve in water. So let's look at A, calcium sulfate. Calcium sulfate is part of CBl, right, for sulfate, so it's therefore insoluble, so it will not form ions at all. Next, we have ethanoic acid. Ethanoic acid is an acid. It has a formula CH3COOH and will dissociate partially in water because it's a weak acid to form CH3COO minus and H plus. So I have 1 CH3COH will form 1 and 1. So it will form a total of 2 ions when dissolved in water. However, it is a weak acid and this dissociation will not be complete. So that means even though I dissolve 1 mole of ethanoic acid, I will not get the full 2 moles of ions that come out. Next, ethanol. So this one is less than 2. Okay, ethanol is a simple molecule and it is also not an acid. So simple molecules, if it dissolves in water, will have no ions, does not form ions because it is a simple molecule. Okay, this is from chemical bonding. Last one, nitric acid, HNO3. HNO3 will dissolve completely in water because it's a strong acid to form 1 H plus and 1 NO3 minus. So if I have 1 mole of acid, it will form 1 mole of H plus and 1 mole of NO3, so it will form a total of 2 moles of ions. And this ionization is complete because it's strong, so therefore the number of ions nitric acid forms is 2, which is more than ethanoic acid because ethanoic acid is a weak acid, which is less than 2. So the answer for this would be D. Next, we have question number 22. So question number 22, it says that 5 grams of X react completely with 8 grams of Y to form a compound of the formula XY2. So let's draw it out, okay? So we have x and then y2. So y. So we know that 1 mole of x must react with 2 moles of y. Over here, we also have information that this is 5 grams, and we also have information that this is 8 grams. Right? We have information that this is 5 grams and we have information that this is 8 grams. But I know that the mole ratio of x is to y is 1:2. So if I can find the number of moles of x, right, I would know I'll be able to find the number of moles of y. So I am given that the relative atomic mass of y is 80. So, and I know the mass of y is 8. So I can find the number of moles of y. So the number of moles of y is equals to 8 grams divided by 80. And I know that the mole ratio of y to x is 2:1. So if x and y is 1:2, and this is 8:80, number of moles of x would therefore be 8 divided by 80 times half, or divided by 2. Okay, so currently, let me just move down a bit more. I know that the number of moles of x is equals to 8/80 times half, because I need to divide by 2. Now, over here, this is the number of moles of x, and the question asks me for the relative atomic mass of x. So how do I know, what formula do I have that combines number of moles and relative atomic mass? So that is the formula, the first formula that we actually learned, right? So let me just move this away. Okay, the formula that we first learned, which is number of moles is equals to mass divided by the MR. So I want to find the MR. So it's MR equals to mass divided by number of moles. So the mass I found, mass I'm given, sorry, is 5. So that's equals to 5. And I need to divide this by number of moles, which is 8/80. That is times half. So now this is the MR of x, and what I need to do is to match it with whatever I have over here. So we can see that we don't have, there's no 13 in our answer, okay, but we have these two. So let's look at this. Which one does it look? So you need to use your math powers and decide that actually the answer should be therefore D. Okay, so that's question number 22. Question number 23. Question number 23, I'm given two compounds, and there is two interesting words that are over here. So over here, they said that the proportion of nitrogen by mass and the proportion of nitrogen by mole. So let's look at proportion of nitrogen by mole first, because that one's easier to count. So let's look at the first substance, which is this one over here. So how do I do by mole? So by mole shows me that there is 1C, 1O, 2N, and 4H. Okay? And for the other substance, NH4NO3, I have by mole 2N, 4H, and 3O. So if I want to find the proportion of nitrogen by mole, I need to calculate like this. In every substance, I have 1, 2, 3, 4, 8 atoms, and I have 2 atoms of nitrogen. So by mole, I have 2/8 of it is nitrogen, 1/4. For the next substance, ammonium nitrate, right? I have a total of 9, atoms, and out of these 9 atoms, 2 of them are nitrogen. So 2 over 9. So we should know that 2 over 8 is of a higher proportion as compared to 2 over 9. So this one answers this. 2 over 8 is more than 2 over 9. So the proportion of nitrogen by mole is higher in this substance here as compared to ammonium nitrate. Okay, so this is by mole. However, by mass is a slightly different calculation. So let's keep this working here, and we're going to modify it slightly to do it by mass. So now, by mass, we need to include the relative atomic mass of each of these atoms. So C is 12, O is 16, nitrogen is 14, and hydrogen is 1. So we need to calculate the total mass. That will be 12 plus 16 plus 14 times 2 plus 4. And then we want to find the proportion of nitrogen by mass. So I have 2 of the nitrogen, so it's 2 times 14. So this is the proportion of nitrogen by mass for the first substance. For the second substance, again, I calculate it. 14, this is 1, this is 16. So by mass, the total mass I have here is 2 times 14 plus 4 plus 3 times 16. And then the mass of nitrogen is 2 times 14.